Hi, I'm Eva Murphy from Electronic Engineering at IT Sligo, and this is my Leaving Cert Maths Grinds channel. I'll regularly add new videos for both higher and ordinary level maths, so make sure you subscribe below and click the bell icon to be notified of new videos. 2017 Leaving Cert Higher Level Paper 2, there was two questions actually on probability, a smaller one, question 3 I think earlier in the paper, and then this question 8b which I'm going to do now. It's a tree diagram and it's quite, a complex enough tree diagram. Very important I think though that you know how to do it. It's a very useful way of figuring out probabilities of event. Basically what's happening in this question is that you take a random school day in Galway and you're trying to figure out if you'll be late or not late for school. Now, whether it rains has a bearing on whether you're late, and whether there's traffic has a bearing on whether you're late. Okay, so let's read the question and let's attempt it. In Galway, rain falls in the morning on 1/3 of the school days of the year. When it is raining, the probability of heavy traffic is a half. When it is not raining, the probability of heavy traffic is a quarter. When it is raining and there is heavy traffic, the probability of being late for school is a half. When it is not raining and there is no heavy traffic, the probability of being late for school is an eighth. In any other situation, the probability of being late for school is a fifth. Some of this information is shown in the tree diagram below. Write the probability associated with each branch of the tree diagram and the probability of each outcome into the blank boxes provided. Give each answer in the form A over B, where A and B are natural numbers. In other words, leave your probability as fractions. Okay, so you can see this is quite a complicated, convoluted setup. If it was just the words you were relying on to figure out the probabilities, then you'd be hard pressed to work it out. So this is where the tree diagram really does come out on its own when figuring out all the different scenarios. So I'm going to take it line by line and I'm going to explain my thinking behind the numbers and how I would tackle it if this were my Leaving Cert paper. So in Galway, rain falls in the morning on 1/3 of the school days of the year. Okay, well, the most important thing to remember in this is that the probability of A happening plus the probability of A not happening generally adds up to 1. So all probabilities add up to 1. So in this case, rain falls or rain doesn't fall. So I'm saying rain falls is the probability of A, the probability of not A, rain does not fall. Okay, and they have to add up to 1. So if rain falls on 1/3 of the days of the year, then it doesn't rain on 2/3. And that's why I'm putting 2/3 in here. So this 1/3 and this 2/3 add up to 1. Okay, and that's that first line taken care of. When it is raining, so we're on the raining branch of the tree here. It is raining, the probability of heavy traffic is a half. Now, I should have explained the key. So rain, they're calling or. No rain, they're saying no or. So there's rain and no rain. Traffic is T, not heavy traffic is no T. So T and no T. Late is L, not late, L and no L. Okay, so that's how I knew this was the branch of the tree that was raining. So when it is raining, the probability of heavy traffic is a half. Okay, so the probability of traffic is a half. Okay, which means that the probability of no traffic must also be a half. Okay, and again, there's either traffic or not traffic. It has to add up to 1. When it is not raining, now we're on this branch. When it is not raining, the probability of heavy traffic is a quarter. So therefore, the probability of not heavy traffic has to be 3/4. So that's that piece filled in. When it is raining and there is heavy traffic, so is raining, is heavy traffic, the probability of being late for school is a half. Therefore, the probability of not being late must also be a half. When it is not raining, and there's no heavy traffic, the probability of being late for school is an eighth. Okay, so therefore the probability of not being late must be 7/8. In any other situation, the probability of being late is a fifth. So for example, it's raining, there's no traffic, there's a probability of a fifth of being late, which means there's a probability of 4/5 of not being late. This is another scenario, no rain, traffic, but the probability of being late is a fifth. Where am I getting that from? Well, it says in any other situation, the probability of being late is a fifth, so which means he's 4/5. Okay, so that's all my branches of my tree filled in. So then to work out all the different scenarios, you follow the path. Okay, so what do I mean by that? Well, this top one here, I would describe that as the probability of rain and traffic and being late. So the probability of rain with traffic and being late. And I'm saying that keyword and in the middle, so it's the and law of probability. So it is a third by a half by a half. So you literally follow the path. So a third by a half by a half. Okay? And if you put that into your calculator, you get a 12th. Okay? The second one. The probability of it raining, so follow the path, raining, traffic, not late. So raining, traffic, not late is a third, because it's the same, by a half again. So this is also going to be a 12th. Okay, the third one, the probability of rain, no traffic and being late. So rain, no traffic, being late. So rain is still a third. No traffic is a half. By late is a fifth. So I'm getting 1 over 3 2s is 6, 6 5s, 1/30th for that one. Okay. The fourth one, the probability of it raining, no traffic, no late, is a third by a half, but by 4/5 this time. Okay, because the probability of no late is this 4/5 here. So put that into the calculator and you get 4 on the top by 30 on the bottom. Okay, all right, the fifth one down. Now we're on to the lower branch, so no rain. So no rain, but there's traffic and we're late. So it's 2/3 by traffic by a fifth. And I'm getting 2 over 4s are 20, 60 for that. So 2 over 60. Then I have the probability of no rain, there's still traffic, no late, is 2/3 by a quarter by 4/5. And that's 8 over 60 for that one. Okay, and then I have probability of no rain, no traffic, but still being late. No rain, no traffic, and still being late is 2/3 by no traffic, 3/4 by still being late, an eighth. So 6 on the top. 6 over 96. Small chance of that happening. Okay, probability of no rain, not late. Sorry, no traffic, not late. So I'd expect this one to be high. 2/3 by 3/4 by 7/8. And yeah, I'm getting 42 over 96. Okay, So that is how you work out all the different scenarios and all the different associated probabilities. You follow the path to bring you to it and multiply the probabilities along the way by each other. So that was part 1, write the probability associated with each branch of the tree diagram in fraction form. And they awarded 15 marks for that question. Okay. Right, continued. Am I right? Yeah. So on a random school day in Galway, find the probability of being late for school. So the probability of being late. Okay. Well, what you have to do is you have to go, well, I'm late here. I'm late here. I'm late here, and I'm late here. So you are okay if you meet this condition if you're on this path, or this path, or this path, or this path. And that keyword "or" that I'm using means I add all the associated probabilities with these paths, because any of those 4 meets the condition of being late. So I would have a 12th from that first one, or, which means I'm going to add a 30th plus this one here, 2 60ths plus 6/96. So that is all the different ways that I could be late. Okay, and put that into my calculator, and I'm getting 70/80 for that one. Okay, so the probability of being late. On a random school day in Galway, find the probability that it rained in the morning given that. So there's conditional probability. Given that you were late for school. Okay, so let's try and write down the conditional piece. So the probability that it rained, so it's "or" first, and then you do the given bit, given that you were late. Okay, it's one of the formulas you have to learn off. How I remember it is it's the intersection of the 2 over the probability of the second one. Okay, so the probability of being late is what we got up here. Right, the probability that it rained and you were late. So let's go back. The probability that it rained and you were late. Okay, so actually it's just the 12th and the 30th that we use in this case. Okay, so let me explain that again. So it's the probability that it rained and you were late. Okay, so that's why I'm not including the lower half, because this was not rained. So just the conditions that you were late where it rained. Okay, put that into the calculator and you get 28/51. Okay, so just to give you a feel for some marks, that was worth 5 marks, that was worth 10 marks, and the tree was worth 15 marks. Okay. If you've enjoyed this video, then why not join us in IT Sligo and use maths in practice. In conjunction with industry, we've designed an exciting new program in electronics and self-driving technologies, which uses cutting-edge techniques such as artificial intelligence, computer vision, and virtual and augmented reality. You'll need a H5 in maths to qualify. Check out the link below.